Dear students of class 9, a very good morning to all of you and hope you all are keeping on fine. In our last class, we had discussed about the three states of matter. We were discussing about the topic matters in our surroundings, and there we were discussing about the three states of matter. As you know that what is matter? That matter is anything that means the universe actually is surrounded by matter. And what is matter? Matter is anything that occupies space and has volume. So you know that there are three states of matter, that is solid, liquid and gases. So can you, you all have already submitted an assignment about the effect of change of temperature on the matter, on the three states of matter. Like when you are, the question arises that there are three states of matter, that is solid, liquids and gases. So the question arises that whether the if there is any change of temperature, whether there will be the change of state. So whatever the assignment you have already submitted through your experimental demonstration, like you know that there are three states of matter, that is solid, liquid and gas, and the most common example for it is ice, which is the solid state, then water, which is the liquid state, and then the vapor state or the steam state, right? So when you are actually taking ice, then you put a thermometer inside it, and then you put the bulb of the thermometer inside it. Then what will happen? You will find that the temperature of which is visible in the thermometer will be equal to 0 degree centigrade. So after that, what will happen when it is 0 degree centigrade? Then you are applying heat on and off. Then you are continuously, not on and off, you are continuously supplying heat to ice. Then at one time you will find that it will melt, and it is cold water. And then if you see the temperature of the thermometer, then you will find that it is still 0 degree centigrade. So similarly, as you go on supplying more heat and heat, then you will find that it will, the temperature will rise, and when the water starts boiling, then you will find that it has turned, means it has risen to 100 degree centigrade. So when you are increasing, why the temperature actually increases when you are when you are supplying heat? That means what happens when you are increasing the temperature of the solid, then the kinetic energy of the particles of the solid also increases. So when you see that water is boiling, then you see that there are some bubbles which comes up, and then they go on vibrating. So this vibration gives you some, gives the particles of the matter more energy, and then they can change the state. And then these particles, they actually they vibrate with a greater speed. So this speed is just generated to the particles, and they gain energy, and then they can change the state. So what do you mean by melting point? Actually, the temperature at which, if you have your book with you all, so you keep your book, textbook along with you all when you watch the video, so that it becomes clear, more clear to you all, to what is being taught. So like just listening to the lecture for you, it might not help, but if you keep the textbook along with you all, I think it will be a better help for you. So if please keep your textbook along with you, and then in page number 7, please underline that word, the sentence, that the temperature at which a solid melts to become a liquid at atmospheric pressure is known as melting point. So that means when you are applying heat to the solid, and then at the means you are keeping a thermometer also in the solid, and then at the time the temperature which at which the solid melts to liquid, please remember that it is atmospheric pressure. Please remember that it has to be atmospheric pressure. So like when you are giving the definition, then what you have to tell that the temperature at which the solid melts to liquid at atmospheric pressure. Please remember, at atmospheric pressure. This has to be specified. So if you tell that the temperature at which a solid melts to liquid is called the melting point will not be sufficient. You have to be very specific about that. Then you have to mention atmospheric pressure, and this is known as melting point. So the definition for melting point is the temperature at which solid changes to liquid, that is known as, at atmospheric pressure, is known as melting point. And what does melting point of a solid indicate? It actually indicates the strength of the force of attraction between the particles. Now what happens here is that, please underline that it is inside the box, the blue color box, that is the melting point. What does the melting point of a solid indicates? Actually what happens when you are talking about solid, they are made up of particles or molecules. So they are, right? So what happens, as you all have already, I have already explained to you all about the group of students, like being divided into 4 categories. One holding the each other with the teeth, right? Then another holding with just like this, and then the other part is holding, and the third group is holding like this. So to break that force of attraction, for you to break easily will be the one who is touching from the fingertip, with the fingertip. Then it will be more difficult for you, the one who are holding each other in this manner, right? So the same thing happens is that melting point means actually when you are applying temperature or supplying temperature, then what happens, the particles are bonded with each other. That means they have, these particles in a solid have a sort of attraction with each other, and that is why as I told you, in solid they have a rigid shape. So when they are having a rigid shape, why they are having a rigid shape? It is because of the force of attraction between the particles of the solid. So what does a melting point of a solid indicates? It indicates the force of attraction. That means the force of attraction that the particles are having and between the particles, and it means the force of attraction that that means the strength. In fact, what is the strength of a force of attraction? That means in suppose in a piece of sponge, as I told you all, that means it has some minute holes inside the sponge, and the air is being trapped inside the small holes. So when you are having a piece of sponge and then you compress it, right? So the air particles goes out. So the vacant space comes. There will be more vacant space, and that is why you are able to compress. But in case of solid, what happens in like a rock, piece of rock, or a piece of duster, the wood, what happens? You go on compressing. You compress this one, and then what happens? It will not move. The shape will be rigid. Why it is rigid? Because that means it indicates the force of attraction between the particles. That means the strength of the force of attraction between the particles, and that is why the piece of duster will not move. Whereas the force of attraction in a piece of sponge is a bit less than what is present in the piece of duster. And please remember that actually what happens here is that we are all having a relation with the Kelvin scale. In fact, there is actually when you are talking about the melting point, it is the relation between centigrade scale and Kelvin scale is 273.16 Kelvin. Please remember, we do not write here degree. We do not write here degree. So it is like 0 degree centigrade is equal to 273.16, and this is the relation between centigrade scale and 270 centigrade scale and Kelvin scale, right? And this melting point of ice, the melting point of ice is known as a melting point of ice is 273.16 Kelvin. That means this is equal to, you know that the melting point of ice is 0 degree. That means this is equal to 0 degree centigrade. Please remember, we do not, as I told you, we do not write degree over here. It is 0 degree centigrade is equal to 2. So as I will just repeat that the melting point of ice is equal to 273.16 Kelvin. That means you can conclude from this point that this is equal to 0 degree centigrade, because you know that in centigrade scale in centigrade scale the melting point of ice is 0 degree centigrade. So that is what that means 0 degree centigrade is equal to 273.16 Kelvin. That means this melting point, this Kelvin actually is the SI unit of temperature. Kelvin is the SI unit of temperature, and this, what we do is that for calculation purpose we take it as 273 Kelvin, because 0.16 will give you some difficulty in doing some calculations. That is why we generally take this 0 degree centigrade as 273 Kelvin, and that is why this Kelvin is means we do not take it as 273.16 to have a simplicity in our calculation part. So the process of melting, that is the change of the solid into liquid, is also known as fusion, right? That means so here we were talking about the calculation part, and then what the process of fusion, that is what is the process in which the solid liquid melts into the liquid is also known as fusion. So, and please remember, please underline it this as the Kelvin down below in page number 7, that is note, it is written Kelvin is the SI unit of temperature, and 0 degree centigrade is equal to 273.16 Kelvin. And for convenience, as I told you, the 0 degree centigrade is taken as 273 Kelvin instead of 0.16, so that it becomes easy for you. It does not become difficult for you, because after decimal it might be a problem to do the calculation. So we take an approximate value of 273 Kelvin, that is equal to 0 degree centigrade. Now, as I told you all that like suppose in your experimental investigation where you are putting the thermometer inside it, then what happens is that you find that the temperature of the thermometer indicates that it is 0 degree centigrade. But as you go on supplying heat, then what happens is that you will find that the temperature still remains 0 degree centigrade. That means you just put a thought to it. That means you are supplying heat, but still then when the temperature of ice was 0 degree centigrade, and when you are supplying more heat, the temperature melts, and then after that when you observe the temperature, you will find that it is still 0 degree centigrade. That means when you are supplying heat to the solid state of ice, of water, that means you are supplying heat, but still then it was 0 degree centigrade, and when it melted, still then it is 0 degree centigrade. So that means where has the temperature gone when you are supplying? That means you are supplying heat again and again, no, to change the solid state of water in the form of ice to liquid. So when you are supplying heat to to change the solid state of ice to liquid, then what happens is that you have supplied the temperature, but the reading of the thermometer still remains the same, that is 0 degree and 0 degree. That means you please give a thought to the fact that where has this temperature or where has the supply of heat energy gone. So you please think it over, and we will have again a discussion about it, and that is known as actually the latent heat. We will have a more discussion, and then till that time please go through the video and have a nice day ahead. Thank you.